Okay, so now we need to figure out how far the car traveled during those 8 seconds, right? Okay, how far did the car travel? How far did the car travel? Oh my God, I know this one right. Okay. How far did the car travel? That is total distance, right? That's total distance. What does that mean? That means I need the integral from 0 to 8, absolute value v of t dt. Okay, great, great. But I don't have v of t. I'm given a of t. Do I have an expression for v of t? I don't have an expression for v of t. I need to find an expression for v of t. So let's do that. V of t is equal to the integral a of t dt. Okay? Now, I need the full expression, not just a numerical value from 1 to 8, from 0 to 8. So I don't want the definite integral. I want the actual expression for the velocity, because then I need to integrate that velocity. Okay? So I do an open integral, and so v of t is going to be the integral of, what was our 2.4t dt. Now, that's going to be 1.2t squared plus c. All right, so how do I figure out what the c is? Do I have an initial condition? What is my initial condition? Here, this is my initial condition. All right, so I know v of 0 is equal to 5, so I need to plug that in. 5, the velocity is 5 when the time is 0. So how much is c? 5. So finally, v of t is 1.2t squared plus 5. How awesome is that? That's the expression for the velocity, right? Given the acceleration. Now, if I need to find total distance, that's going to be the integral of the absolute value of 1.2t squared plus 5 dt. Now it's from 0 to 8. Okay, this we can do with the calculator. What does that give you? $244.8. What are the units here? Miles. Okay, so take a look. Check it out. It was in miles per hour, right? Initial velocity of miles per hour. So now this is all miles. So now what do I need to do? If divide by how many seconds are in an hour? How many? 3,600. Divide by 3,600, and then finally it's 0.068 miles.
To get rid of the hours.
Correct, because initially the velocity is given in 5 miles an hour, and then the acceleration is given in miles per hour, but then we're gonna go in seconds. Okay? Yeah.
They'll never give you the like the velocity is in 5 miles per hour and the acceleration is not like a different not miles per hour. They'll keep those the same.
They could, because you could convert between miles and feet. 5,280 feet per mile. So technically, yes, they could be. There is not a rule that they all have to be in a certain unit. Yeah. Okay. Possibly, right? But that doesn't change the fact that you know. Yeah. Okay? All right. So let's think about this a little bit more. Here we integrated the acceleration, right, in order to figure out how much velocity was built up from 0 to 8, and then we added that to our initial velocity, right? So if I'm accelerating 2 miles an hour, right, if I'm accelerating 2 miles per hour, then, you know, like in the first hour, I'm going 2 miles per hour faster, and then 2 miles per hour faster, and then 2 miles per hour faster, and then, you know, over 8 hours, I know how much velocity I've built up. That's what we're doing when we integrate. Now, something is changing, and we're calculating how much of a change has occurred, right? But velocity and acceleration are not the only things that change, right? Lots and lots of other things change as well. So let's do an example of something else that's changing. So I just said, in different words, that the integral is a way to calculate net change, right? And the total accumulation of quantities more than just velocity and acceleration, all right? So if somebody's noticed that their grade on a test increases 1 percentage point every other test, right? So like they got a 74, and then 2 tests later it's 75, and then 2 tests later it's 76. You can calculate after 10 tests how much their grade will increase, right? Yes? How do we do that? Because it's like accumulating. We integrate. Integrating just adds all that up for us, sums all that up. Remember? Okay, so integrals can also be used to calculate growth, decay, consumption. So basically, to find the cumulative effect of a varying rate of change, you integrate it. Okay? Something is changing, you integrate it to find how much it's changed. Okay? All right. From 1970 to 1980, in those 10 years, the rate of potato consumption in a particular country was that, because for somebody, it was super important to calculate how much potatoes were being consumed per year. Okay? And it turns out it was 2.2 plus 1.1 to the power of t. That was the rate of change. Okay? Okay. So what is this? This is the rate of potato consumption. Give me an example of a rate. Give me an example of a unit for a rate. A rate, a unit, a rate. Meters per second. What else? What did you? Miles per hour. What else? Meals per day. What? Gallons per whatever. So every single one of you said blah per blah, something per something. So that means rate, right, has to have units of something per something. Remember last year when we were doing pre-calc, it was inches squared per inch at one time. So it could be whatever it is. It's just something per something else. So this is the rate of potato consumption in millions of bushels per year. That's important. Millions of bushels per year, with T being the years since the beginning of 1970. How many bushels were consumed from the beginning of 1972 to the end of 1973? So what I have is the rate, and that's millions of bushels per year, right? What I want is bushels or amount. So if I have bushels per year, what should I multiply that by in order to end up with just bushels? A unit of time, right? So I need to get the rate, multiply it by a unit of time so that the time cancels with the time. Okay? So T equals 0 in 1970 here, and T equals 10 in 1980, right? Okay, so what happened here? How many bushels were consumed? So how many bushels from the beginning of 1972 to the end of 1973? What are the years here? When it's 1972, T is what? T is 2. And then the end of 1973, T will be 4, right? Because it's like December 31st, 1973. So from the beginning of T equals 2 to T equals 4. Okay? So we're going to set up the integral. We're going to set up the integral. And we're going to go from 2 to 4. Okay? Now remember what we said we had to do? We had to get the rate and multiply it by time. Well, what is the rate, you say? 2.2 plus 1.1 to the power of t. Right? How do I multiply this by time? I say dt. Right? dt, that's time. This is the rate times the time. I'm going to get bushels. Come on, that's cool. Tell me that's cool. Okay, so put it in the calculator. Tell me what you get. How much? 7.066 what? Millions of bushels. So that the people in that country had 7 million bushels of potatoes from 1972 to 1973. It's probably like Northern Europe or something, man. Those, huh?
Or Idaho.
Those, but it's a country.
Yeah, Idaho.
Those like Northern European countries, you know, like the Viking descendants, man, they eat lots of meat and potatoes.
Ireland?
No,